So, Mike, engineers these days have so much on their plates, dealing with IT, dealing with RF, dealing with room design in some cases, and mic processing isn't always at the top of the skill list. What do you tell an engineer who hasn't had maybe a lot of experience setting up mic processors and might have some challenging rooms? How do you get them started with figuring out how to work with these boxes?
One of the ways we tackle that, not only with the presets, and we say that they're good starting points, we encourage people to reach out. If you're stuck, if you don't understand it, or if you've never done a mic processor before, we encourage you to reach out. The other thing we've done is use terms and controls in the mic processor that are ubiquitous to the industry: compression ratio, attack and release, as I said before, EQ controls that basically raise the bass, raise the treble. We're not putting any fancy controls in there that may end up being more harmful than good if they're misused. We try to refrain from using proprietary names on our controls. One of the things that we got into way back when Wheatstone started was to be able to give you controls that actually had the values of what was actually going on, rather than random numbers that were like 0 through 7 or 1 through 100 or something like that. The controls, the timing controls, attack and release, the timing, that's actually what's happening. The best way to approach this is to keep it simple. And that's what we think we've done. We've designed, we feel, very elegant algorithms in the compressor, in the de-esser, in the expander, that allow you a lot of latitude to make these changes without running the car off the road. It's very easy to get a presentable sound out of the M1, and not that much harder to get dynamite sound. Again, all the other factors we spoke about, you have to take them into consideration. But even in challenged rooms, you can get really good microphone audio using the tools that we give you in M1 and M4.
And you're here to help?
And we're here to help. That's what we do. We're definitely here to help. We have some ways of being able to, a lot of people, I tell them, is like, can you give me a dry recording of the microphone with the presenter in the room that they're in? And then I can bring it into our lab here. I can actually plug it into the M1 or the M4 and kind of make a preset out of it. And we do have mics. We have Shure SM7s, we have RE20s, we have Heil microphones, we have condenser microphones. It's one thing to be able to say, okay, I have an RE20 and I need to have a good sounding preset. Well, the acoustics in this room are much different than the acoustics you're going to find in the room where that preset's going to be used. So I always tell people, if you can get me a dry solo recording of the on-air mic. If it's a morning show, maybe get the co-host in on it as well. So I can hear not only the interaction of the mic, I can hear if there's any reflection from one mic picking up the other. Sometimes I'll ask the customer if you can record the one mic in the left channel and the other mic in the right. So this way I can solo one of the channels and hear what one of the mics is picking up off axis. A lot of that goes into making a preset that can help, reduce the annoying background noises and other abnormalities you don't want on the air, and just focus on the presenter on that one mic channel.
So, Mike, with the M4 IP, this is basically in blade form. Are you limited to just working with mics that are in the same room as that unit?
Well, that's what you would want. The unlike the other blades, which basically each blade, as you know, hosts an audio signal. So if you've got a blade in a rack room and you've got some device that has standard left-right analog out, or AES, you come into a blade and that signal then gets distributed. The M4 is basically the entry point for microphone audio into the WheatNet system, and you can then use the processing to sweeten that microphone up. So the input is affixed on the analog in, because you got and it is only analog. Obviously, we don't have AES microphones yet. So that's the point at which the mic level becomes line level and then can be distributed throughout your system. So most M4s are placed in the studio to prevent long cable runs for microphones, which is verboten.
Good engineering practice.
Very good engineering practice. The part of the M4 that a lot of people sometimes don't realize is that you don't need WheatNet in order to use an M4. The M4 can be used as a standalone processor. So while it can distribute audio in a WheatNet system from the microphone inputs, it can also have those microphone inputs physically on the output, so you can traditionally wire them to a console, either analog or AES. What's nice about the M4 using it in standalone is that it's easy to cross-pollinate presets between the 4 different instances of mic processing. It saves rack room. It's a very robust piece of gear. I've seen them a lot in radio stations where you got like a 20-year-old Wheatstone console and there's an M4 in the rack processing the microphones. So, and that's what's cool about it.
Mike, thanks for spending some time talking with us about voice processing. What are some other resources people can hit up?
Well, we have a lot of information on our website, wheatstone-processing.com, or you can give us a call right here at Wheatstone. We'll be happy to help you.
Thanks so much.